Hey everyone, Spencer here on top of the Grand Mesa Lodge. Also, I run a YouTube channel called Summit Secrets, and for anybody who hasn't watched my videos before, I own a lodge in western Colorado on top of a mountain called the Grand Mesa. The lodge is called the Grand Mesa Lodge. And right now, I'm actually looking for a group of NASA scientists that are conducting a study somewhere to the west, kind of to the northwest of where I currently am. In fact, NASA has been running this study on top of the Grand Mesa for a couple of years. They come here every year in the wintertime, sometimes a couple of times. And it's a really interesting study. They're trying to use high-tech equipment, radar, and other instruments in order to analyze and measure the snowpack. Not just the depth, but also the water content of the snow. And so I'm gonna cruise out there and I'm gonna link up with these NASA scientists and I'm gonna bring you all the information. I'm gonna ask them questions. What are you doing? What's the scope of the study? How long has it been going? We're also gonna talk about the impacts and the benefits of what this study could mean for the United States as a whole, but also for individuals. Also, quick disclaimer. NASA and this study is a publicly funded study, so they in no way are endorsing my lodge or any other private business. It's a publicly funded study. I'm going to jump on here. I don't know exactly where they are. I know the general idea, but I'm going to find them, and don't you worry, I'm a good tracker. There's about 15 scientists, but they're all in smaller groups of 2 or 3. Stay tuned. All right. Let's go find those scientists. So it looks like there's a group of, could be snowmobilers up here. I honestly can't tell if it's trees or snowmobiles, but we'll go check it out. Also, an airplane just flew by, which I'm pretty sure is part of this study. I'm pretty sure this is them. So we'll zip over there, and if it is, we'll ask them some questions. How's it going, Thomas?
Hey, pretty good.
What's the scope of the study, and what do you hope to accomplish?
Yeah, so this study that we're out here doing, I'm flying a KU and C-band radar, so 5 to 6 and 15 to 16 gigahertz radars. Our goal is to measure the snowpack. We want to see how deep the snowpack is and how dense it is, and
cool.
With those two variables, we can get out how much water is sitting out.
All right, I'm here with HP, and we're going to talk a little bit about this study as far as the organization and anything else you want to talk about. But let's start off with the study itself. It's a NASA-funded study, but you don't actually work for NASA, right?
I don't work directly for NASA, no. We got a proposal funded that is part of this NASA program called the Instrument Incubator Program. And this is a program that funds instrument development with a goal of building instruments to a stage where they're ready for spaceflight. So we start by testing them from the ground, testing them from drones, testing them from aircraft, and then eventually hopefully launch a satellite with it. So we have the aircraft that just flew over us is a group out of University of Houston.
And that airplane came from Houston.
That came from Houston.
Today it launched from Houston, flew over here,
Yep.
and ran this.
And they are part of the National Center for Airborne Laser Mapping, and they do airborne mapping of topography at very high resolution all over the country.
Oh, cool.
We're using it. They map the surface of the snow. They also flew for us in October, and this was all coordinated by the U.S. Army Cold Regions Research and Engineering Lab, who's also here. And we take the difference between those two surfaces, and it gives us a very high resolution map of snow depth, and we use that to validate some of the airborne radar observations that we're making. So the other partners, the overall PI of the project is from University of Massachusetts, and they are up in the plane right now on a different aircraft overflying the mesa here with a sensor that has the capability of mapping the amount of snow on the whole Earth at regular intervals all the time. We don't have that in space yet, but we're testing it here from an aircraft plane.
And that's the ultimate goal.
That is the ultimate goal.
Take what you're doing, figure out how to do it with drones, with airplanes. Once
Yep.
you have it dialed in and it works, then you put it on a satellite, launch that into space, and then that flies over the Earth.
Yep.
And theoretically, boom, now you know total water content for the whole planet
Yep.
in the snowpack.
And it really is one of the biggest uncertainties in the hydrologic cycle.
Sure.
It would benefit us by making better decisions about water management.
Okay, so my next question is, there's a lot of places with snow. Why are you on Grand Mesa?
We're on Grand Mesa because topography can be one challenging aspect, and we're trying to isolate the different controls over how the sensors interact with the snowpack. And so by working on Grand Mesa, it's one of the few places where we can be pretty much guaranteed to get dry snow because of the high elevation, but we remove the effect of topography, which is fairly complicated. The coordination of these campaigns is really complicated. Like, we have folks from the U.S. Army Cold Regions Research and Engineering Lab. We have people from Dartmouth College on the East Coast. We've got people from Colorado State University, from Boise State University. So we're bringing a lot of people together. One of the advantages of working here is we can stay at the Grand Mesa Lodge, drive once to get here, set up all of our equipment, and then just leave on snowmobiles from the cabins every day.
What's the study called?
Snowy, the snow water equivalent wide swath interferometer. Interferometer is just a type of radar that is sensitive to both the amplitude and the time of flight of the signal through the snowpack.
Cool. Snowy.
Snowy. Yeah.
Got it. Cool.
Gotta have a good acronym.
Yeah,
NASA
thank you.
loves
I
acronyms.
know, right? all the government agencies do. So I just left Thomas and HP, and now I'm going to go find this other team. There's two other NASA scientist teams out here somewhere, and I'm going to go find them.
.6.
78.9.
78.9.
76.3.
76.3. Yeah, the idea is to try to characterize the stratigraphy, because the radar can penetrate through the snow and interact with the different layers and tell us something about the density and snow water equivalent of each of the layers. So if we characterize it, like the aircraft can't characterize it as well as we can in the ground,
Right,
obviously,
yeah.
but the radar, we're trying to find that out. Yeah, so NASA's interested in the global water cycle, so they're interested in measuring impacts to the global water cycle, and snow being one contribution to that water cycle.
Yeah.
And especially in the West, where folks rely on the snowpack for their seasonal water supply.
That's cool.
So Tate, you want to tell us about the instrument that's on your rib now?
So,
What is this thing here?
yeah, what we've got here is actually two different instruments. This right here is a laser altimeter that is essentially just measuring the height to the snow surface, and we have a highly accurate GPS unit that's giving us the absolute elevation.
Oh, cool.
If we subtract that surface height from the known ground surface, we get snow depth with this instrument. So this
Oh, wow.
when we process that, we'll get snow depth, and we're going to combine the snow depth information, which they're also flying on the aircraft with, it's called LiDAR. So they're flying LiDAR over us right now. My research has been combining LiDAR with what we've got here is a ground penetrating radar. And so the radar is sensitive to both the depth and the density. And essentially, if we combine the LiDAR and the radar, we can solve for the snow density.
Oh, interesting.
And yeah.
So the airplanes have LiDAR, not radar, on them?
There's two planes flying, one with LiDAR and one with a radar on it.
Interesting.
Yep.
So what's the benefit of LiDAR versus radar?
Well, the good thing about LiDAR is it can get us snow depth and with really complete coverage from the aircraft. And then again, because the radar is sensitive to the total snowpack, essentially combining those two instruments allows us to most accurately solve for the water content of the snow.
I got 2 snowmobiles, get ahead.
You get the map and all that.
I get the what?
The meteorology.
Yes, I did. Few clouds, calm wind.
Some other little plants I don't know in here, but I'd go with 80% grass.
Okay.
Are we?
We're a bit behind. We were hoping for today, but let's see once they finish if we have time for one more.
How far apart do you do them?
These have been like 200-300 meters apart,
Yeah.
but then the whole stretch is much more.
In a straight line going this way, right?
Yeah, this one is like more or less north to south straight line.
Yeah.
That matches kind of the overflight pattern, because we have like one north-south line,
Yeah.
and two east-west line,
So the airplane can just fly directly over.
yeah,
Yeah, cool.
and then we have good sample points in the middle, because you know it best, right? All these drifts
Mm-hmm.
that
Yeah.
form built here changes
Right.
the scenery a lot.
Something for the aircraft, or
No, he
is he just?
Yeah, he has a ground penetrating radar.
Oh, right now on his snowmobile.
Yeah,
Oh,
yeah.
interesting.
He's getting sort of a continuous profile of the
cool.
snow properties.
All around 360 degrees around that pit.
So it also serves as a validation for the radar signal we measure from the aircraft.
Oh, gotcha. All right, so I'm here with Zoe, and we're down in a pit they just dug. Did you help dig it?
I did not help dig it.
You're
I had to. I was looking at the depths all in spirals around the pit, so I was out for a little walk while they were digging it.
what the heck are you doing? Why are you digging a pit in the snow
That's a really
on the
good
top of the Grand Mesa?
That's a really great question. So we currently have a new, almost prototype instrument that's flying on a plane overhead, and it's a radar that's sensitive to the depth of the snow and the density, and can tell us about how much water is stored in the snowpack, which is really the holy grail of being able to determine snow properties. And eventually, if this works, this prototype instrument will go on a satellite. And because it's a radar instrument, it's really sensitive to snow microstructure, which is my part of this process. I'm in charge of taking samples from the pit, and I'll take them back to the lab. We have this instrument that is called a micro CT, and it's basically like a CAT scan that you get in a hospital.
Hence CT.
Yeah, hence CT. So it's just like a CAT scan, but it's in a cold room back in our lab in New Hampshire, and we can get 3D X-rays of the snow microstructure at very fine scale.
So you take the snow with you?
Yeah.
How do you keep it cold?
We have dry ice
Okay,
that we use
cool.
to ship it back.
So you're going to take snow from here.
Yeah. We're gonna
Yeah,
ship
cool,
it
good.
back to New